All right, good. Let's now look at, we are in for lesson 2 of linear motion, part of mechanics in mathematics, paper 2, which we call applied math. Number 1, they are saying a body starts from rest. A body starts from rest and accelerates uniformly at 5 meters per second. Please, accelerates uniformly. Whenever you see the word accelerates uniformly, then it means that the equations of motion I'm going to use are these ones. Whenever you see this word in the question, you just know these are the equations of motion I'm going to use. Accelerates uniformly, 5 meters per second. First of find its velocity after 6 seconds. The velocity after 6 seconds. So therefore, we shall say now we shall now say, let's now summarize the saying. A body starts from rest, mean that its initial velocity, if it started from rest, mean that its initial velocity, u is meters per second. Please, you go in lesson 1 and get to know where we noted about how do you tell when you see these statements here. You go and watch lesson 1. Okay. U is equal to 0 meters per second. Now, accelerating uniformly. So, acceleration is equal to 5 meters per second squared. These SI units are provided in the lesson 1. You go in the playlist, the first video. Okay, at rather find its velocity after 6 seconds. This 6s meaning 6 seconds, and that's what time. So time is 6 seconds. Now do they want? They want its velocity after this. And if you have the initial velocity, then they just know that they definitely the velocity they're asking for is the final velocity. Now you go and look at the 3 equations you have. Which one correlates with this? You look at which one correlates with this. Where you have U, A, T, V. Where is that arrangement? So that we have this equation 1, it will work for us. So now I can now say that from, okay, V is equal to U plus AT. So our V, we have it, no? So V is equal to, our U is 0 plus our acceleration is 5 times the time is 6. So now our V will be equal to 5 times 6. That will give you 30 meters per second. And now that's the velocity after 60 seconds. Number 2, they're saying a body moved along a straight line from point A to B with a uniform acceleration. This one, uniform acceleration implies you're going to use those equations there. Okay, 2 over 3 meters per second squared. This one tells you that this is the SI unit for acceleration. You go in the playlist video 1, then you see how we explained that. Okay, good. The time taken is 12 seconds and the velocity at B is 25 meters per second. Full stop, find Roman number 1, then Roman number 2. Okay, now what you must know, where necessary, you can always make a sketch. Where necessary, you can always make a sketch. And with this, I'll make a sketch since they're using letters. So now say solution. You can make a sketch where necessary. Okay, solution. Now we have from A to B, have this. It is in a straight line, so I'll use a straight line from A to B. Now just know that this A is the start, and this B is the one which gives us the end. And now they are saying a body moved along a straight line from A to B with uniform acceleration 2 over 3. Now its uniform acceleration, the acceleration A is 2 over 3 meters per second squared. I'm summarizing. Second squared. The time taken is 12 seconds. The time taken is 12 seconds. I'm summarizing. Okay. And the velocity at B is 25 meters per second, but B is the end point. So the velocity at B is 25 meters, but B is the end. Meaning that if it is a start, this will shall have U, here we shall have V. So if they say velocity at B is 25, therefore, the final velocity V is 25 meters per second, like that. Now what do they want? Find, remember number 1, velocity of A. But the velocity of A is the velocity at start, which is the initial velocity. So U will be equal to, we don't know. Now you look at this arrangement and see which equation will you use. We have the ATVU. ATVU would still be this equation 1. So now shall I say that V is equal to U plus AT. So therefore substitute. The V is 25 given to us is equal to U plus A, which is a 2 over 3 times the T, which is 12. All right. Shall use this area also. So this one will be, okay, we shall still have 25 is equal to, when try to cancel this, gives us a 1 here, it gives us a 4. So we shall have that U plus 8. U plus 8, because 2 times 2 is 8. When you correct like terms, you realize that the U will be equal to the 25 minus 8. So therefore, what will now be our u. 25 plus 8, I think this one will be 17 meters per second. As simple as that. And now that's our initial velocity or velocity at A. Then finally, Roman number 2. Here we have answered Roman number 1. Roman number 1. Okay. Now Roman number 2, what are they saying? Now we always, however much you got Roman number 2, we always use these very details we have at start. All right. So now they're saying velocity of B. Oh no, please, that can't be, because we already have the velocity of B, and that question we shall correct it to distance. Actually, it's meant to be distance AB. It's meant to be distance AB, by the way. It's meant to be distance AB. Distance AB. All right. Now, distance is the same as displacement. We explained that in the first video, lesson 1. You got to watch it, please. So now here we shall say that now our displacement S is we don't know, but we have the other details. So therefore, the details we have is our A is still 2/3 meters per second squared. That is acceleration. Our T is equal to 12 seconds. And now our, okay, we have everything. Even the U, we have it. The U is 17 meters per second. Like that. Now, let's look at this, please. Let's look at this. We have S, A, T, U. SATU, which equation? I think second equation. So using S is equal to UT plus a half AT squared. That's what you shall use to get the displacement. Distance is the same as displacement, please, as far as these equations are concerned. So S is equal to U which is, okay, 17 times AT, which is 12, plus a half times acceleration, which is 2/3 times AT, which is a 12 squared. Okay. Now from there, let's calculate. Press in our calculators and have that answer. The answer must be in meters. So you press your calculator. Now if I'm trying to press here, I'll have 17 times 12. That will give us 204 plus 30 times 144. So here we shall have S is equal to 204 plus a third times 144. All right, because 12 squared is 144. Why a third? This 2 has cancelled. Like that. Now your S, the final answer will give you is 252 meters. That will be our answer, 252 meters. And that's now the distance AB. When you say distance AB, the distance from here up to here, then that's what we have. There's another version, another method of using V squared, but that one, you can also use it and it gives you the same answer. Okay, let's still proceed. Okay, now we have example 2. We have example 2. Okay, they're saying a car traveling at 10 meters per second. Let's summarize straight away. So now the solution. Let's say traveling at 10 meters per second, accelerated at 4 meters per second until it was 18 meters per second. And so that you have two velocities. We have this one and this one. Accelerating at this, we have this and this. That is not mean the initial, this is final. So a car traveling at 10 meters per second, that will be our initial velocity, is equal to 10 meters per second. Okay, accelerated at, so our acceleration is 4 meters per second squared until it was 18 meters. So that's the final velocity. P is 18 meters per second. Okay, take note of the SI units. Full stop. Now part A they're saying how far, part A they're saying how far did it travel during its acceleration? How far did it travel during its acceleration? How far? Now how far means distance. So how far, I'm answering part A. How far means distance or displacement, which you don't have. Now we shall say, look at the details we have. Look at the details we have. I have U, A, V, S. Which equation of motion can work? It is this one. So now we shall say from V squared is equal to U squared plus 2AS. Do not know how far. So V is 18 squared is equal to, okay, 10 squared plus 2 times the A, which is 4 times S. Therefore, that means that if we ask to start with, okay, that will be now 18 squared. Bring this side, minus 10 squared will give us 2 times 4 times s will give us 80s, like that. Now 18 squared minus 10 squared on your calculator. 18 squared minus 10 squared on your calculator, what will you have? That will be 324 minus 100. 324 minus 100 is equal to 8s. Then it will give me a 224 is the same as 80s. Divide both sides by 8. Divide both sides by 8. Now divide on your calculator and tell us what the s is in meters. Displacement is measured in meters. And when you divide that, you will see that your answer will be 28 meters. 28 meters. As simple as that. So I've answered part A of how far. Then part B, they're saying how long did it take? How long means time. When they say how far they want displacement. How long they want time. So how long did it take to effect this change? How long? So that is time. Therefore, part B, they want to know how long. We don't know, all right? But we have that information already. We have our A as 4 meters per second squared. Okay, we have our V as 18 meters per second. We have our, okay, even the S, we have it, we can add it on there, 28 meters. All right, now how shall we get the time? How shall we get the time? Oh, we even have the U. We even have the U, which is 10 meters per second. Now once I have the U, what shall we have here? You realize that we want it, we have A, we have V, we have U. So you can use the first equation. So shall say using U, V is equal to U plus AT. They want how long, that is time. So this is 18 equals to 10 plus a 4 times T. Because 4 is the acceleration A. So this will now be 18 minus 10 is equal to 40. You can see that. So 18 minus 10 will be give you 8 is equal to 4t. Divide by 4. Divide by 4. What are we going to have finally? This cancels out. I find that t is equal to 8 divided by 4. You'll get 2 seconds, because time is measured in seconds. As simple as that. Okay, we are in for example 3. Example 3 says, a train traveling along a straight line with a constant acceleration. I told you when you see this statement, a constant acceleration, then you just know you have to use the equations. It's observed to travel distances of 1 kilometer, in times of 30 seconds and 20 seconds respectively. Meaning that here, when the meaning here is that here in 30 seconds it covered 1 kilometer, even in 20 seconds it covered 1 kilometer. You must understand that. Respectively, a full stop. They're saying calculate the acceleration and initial velocity of the train. Okay, now I told you where necessary, you can make an illustration. Where necessary, you can make an illustration. Now let's try to make an illustration here. I'll consider, since this train moved two distances, like from here to here, there to there. Allow me to call these distances A, B, and C. Like it traveled distances of 1 kilometer in 30 seconds and that. So, mean that in this first case, the time taken for the first from A to B was 30 seconds. Then the time taken from B to C is 20 seconds. You must put, please, the S is meaning seconds. All right, now from there, it was covering, in every case, it was covering a distance of 1 kilometer. Because they say it's observed to travel distances of 1 kilometer in times. Distance of 1 kilometer in times. This now means that in 30 seconds covered 1 kilometer, even 20 seconds covered 1 kilometer. Okay. So means that here it covered 1 kilometer as well. Even here it covered 1 kilometer. But what you must put into consideration is, this is our start and this is our end of the motion. Okay? Good. Meaning that you expect the initial velocity here and the final velocity there. All right, good. Now, what must you know? You have here this one is 1 kilometer, but we don't always report distances in kilometers. We say distance and displacement is measured in meters. So therefore, I will say that my S my S is the same as 1 kilometer is equal to 1,000 meters. Even here, my S is equal to 1,000 meters. As simple as that. As simple as that. Okay. Let's now proceed. Let's now proceed. Let's now proceed. Now what will it be? We shall now consider in cases, but we all began from here. So we have a common letter which is A. So we shall now say that, we shall now say, have they given us any other information here? Okay, that's all. So now if they're always asking for calculate the acceleration and initial velocity, whenever they're asking for two unknowns in one question, just expect a simultaneous equation. So let's say now case one. There are two cases, case one, but in all, what you must know, everything started from here. You start from here and reach here. You start from here and reach there. It means that our A is a starting point in both cases. So case one, we are going to consider AC, distance AC. Now distance AC, what must we expect? For distance AC, case one, we know that our S is 1,000 meters, 1,000 meters. Okay, what else do we have here? Our time in case one, that is from, let's start with AB. That is AB. So from A to B, distance covered is 1,000 meters. Then the time T is 30 seconds. Then what are they asking for? They're asking for the acceleration A, we don't know. It is constant for both of them since this one vehicle. Okay, or a train. Then the initial velocity. Initial velocity is the same because it is one train. It all started from here. Therefore, the U is we don't know. Like that. Now, look at this information. You have STAU. Which equation I'm going to use? I'm seeing equation number 2. So that will be S is equal to UT plus half AT squared. Very good. Substitute. Shall have here 1,000 is equal to U is we don't have. So U times 30 plus a half times, do you have the A? No. Times A times 30 but squared. So you can now harmonize that area. There. So find out what are we going to have. What are we going to have when try to divide or simplify? What are we going to have in the end? So what we're going to have here is, okay, this one is going to be, let me start with this. 30 times U will be 30U plus, simplify here. Now 30 squared will give us 9,000. 9,000 divided by 2, it will give us 450. So plus 450, but the A is there, must be equal to, please I'm simplifying this, plus this equal to this, must be equal to 1,000. Then I will call this one my equation number 1. Then from there, shall now go to case 2. Case 2. Now case 2, let's go to case 2. So case number 2. So in case 2 here, what are you going to do? Case 2, you're going to consider, since A is the starting point, so we started the AB, case 2 will be AC. Why AC? Because our initial starts from here. It's a common for all of them. AC. So therefore case 2 is A and C. So AC will be, let's now harmonize it. So what will be our S? The displacement from A to C. Remember, we have 1,000 plus 1,000. This is 1,000 plus 1,000. So that will be 2,000. 2,000 meters. Okay. Then the time T. What will be the time? Remember, we have from this here up here is 30 plus from here up here is 20. So T, the small t is 50 s. Full stop. Okay. Now what else? We don't have the A and we don't have the S. We don't have that. So what are we going to have in the long run? Simplify it from here. So now we shall say using S is equal to U T plus a half AT squared. And now what I'm going to have here is our S is 2,000 is equal to, okay, U, that will be now 50 times T plus a half times A times the 50 but squared. That's great. Then let's simplify. Let's simplify here. Here we shall have 50t. I'm beginning with that 50t plus. Let's reduce that on our calculator. That is 2 another 50 squared. 50 squared will give us 50 squared will give us, okay, here we have a 50 squared. A 50 squared, so that's 50 squared will give us 2,500, 2,500, 2,500. So it'll give us 2,500, but divide by 2 will now give us a 1250A. Please square this, divide by 2 to give it 1250A is equal to a 2,000. And this is now our equation number 2. From there, now we have equation 1 and equation 2. So we shall now say solve 1 and 2 simultaneously. Solve equation 1 and equation 2 simultaneously. Okay, like that. Then everything will be okay. Now solving those two equations simultaneously will mean that we shall bring these equations together. But maybe if I try to reduce them, you look at this. Try to reduce all through by 10. When divide all through by 10 on this equation 1, we divide all through by 10, you shall have 3u plus divide by 10, you shall have a 45a is equal to divide by 10, you shall have a 100. So I'm requesting we take this as equation 1. Then also when I reduce this equation 2 by 10, shall have, shall have 5t by 10 plus 12 5a by 10 will give us 200. This is equation number 2. I've reduced on the values. Now let's solve them simultaneously. So therefore we'll say this is u. No. Oh, this is 50 times u. Because it was ut. The u, we don't know. The t was the 50. 50 times u, so it gives us 50 u. 50 u. Sorry. Okay, good. Now this one will be, okay, we're going to have 5u plus 12, 125a is equal to 200. We're going to solve it with a 3u plus 45a is equal to 100. All right. Let's use elimination. You see that here we shall put a 3, then here 5. And try to multiply, you're going to have a 15u, a 15u. You're going to have the 15u. And let's also press. This will be, 12, rather 125 times 3 will give us a 375. So plus 375a is equal to 3 times this will give us a 600. We are going to subtract, remember, this will be 15u. 45 times 5, 45 times 5 will give us plus 225a is equal to a 5 times this will give us a 500. All right, we are going to subtract. When you subtract here, we get a 0. A 15u minus 15u will be a 0. No need of writing it. Then have a 375 minus a 225. It will now give us 150. So this will be 150a is equal to 600 minus this will be 100. Like that. If I'm not mistaken. Anyway, that will be 100. So divide both sides by 150, both sides by 150. This and this will go away. So it will be your acceleration. Acceleration will be, okay, a 10 over 5, that is 2 over 3. 2 over 3 meters per second. That has been a 10 divided by 15. Right, about 2. Oh, is that so? So here we have this and this goes away. By 5 here we have a 2. By 5 here we have a 3. If I'm not mistaken, that is the answer. If I'm not really mistaken, that is our answer. Okay, now let's proceed. And that is meters per second squared. Let's now proceed. Now, they wanted the value of the acceleration, then the initial velocity. So we have the acceleration, then all you need is initial velocity. So we have the A. So you can now say from an equation of your choice. So from equation 1. Equation 1, where are you? It is 3u plus 45a is equal to 100. We need it to get u. So 3u plus 45 times A, which is acceleration, which is 2 over 3, is equal to 100. That's what you're having. So let's proceed now. Let us proceed. You realize that we shall now have, okay, a 45, okay, have 2 over 3, 2 over 3 times 45. Okay, this will just give us 30. So this will be 3u plus, okay, simple times 30 is equal to 100. So that will be 3u is equal to 100 minus 30. Therefore, 3u is equal to 70 divided by 3 divided by 3. So now our u will be equal to a 70 over 3 meters per second. You can write it in decimal form, no problem. You can write it in decimal form, no problem. And that's how simple that number was. Thank you. Okay, so let's now look at the example number 5. A driver of a car traveling at 70 kilometers per hour notices a tree which has fallen across the road 800 meters ahead. So shall I say solution? Solution. So now 800 meters, that is the displacement. 800 meters ahead. And suddenly reduces the speed to 36 kilometers per hour. Reduces the speed to 36 kilometers per hour. So reduces the speed to 36 kilometers per hour. Reduces the speed to 36 kilometers per hour by applying the brakes. Okay, so a driver of a car traveling at 72. Now we see that we have two speeds. We have this one and we have that one. But this one is the initial speed. So u is equal to a 72 kilometers per hour, like that. Then a v is equal to the final velocity, 36 kilometers per hour. This after the man had reduced. Please, sample take it from framework that the biggest velocity is always the final velocity. No, follow the question. They are saying a driver of a car traveling at is already traveling at that. Then reduces the speed to, meaning that this one, the 72 was the first one he was traveling. Then when he reduced, it was after the 72 had occurred. Therefore, 72 is the initial velocity and the 36 is the final velocity. By applying the brakes, stop. For how long? I told you so. How long means they want you to find the time. For how long did he apply the brakes? They want us to get time. So t is we don't know. Now, if we don't know time, then what must we consider? First of all, the velocities, as we know from lesson 1, you can go in the playlist and watch lesson 1. We said that the initial velocity is must always, all the velocities must be in meters per second. But the ones we have here are in kilometers per hour. So, meaning this must be changed into meters per second. Even this guy must be changed into meters per second. That must be done with immediate effect. And the answers shall put them in the brackets. Okay. Now let's see how we convert. Let's see how we do the conversion. Like we have 72 kilometers per hour. This implies that this in simple terms means a 72 kilometer over, this word slash means over hour, like that. Now what does it mean? But you're converting to meters per second, meaning that we must convert this into the upper one into meters, the down one into seconds. Therefore, convert the 72 kilometers into meters. That will be 72 times 1 kilometer is equal to 1,000 over 1 hour has how many seconds? It is 3,600. And when you reduce that, you'll get 20 meters per second. So I'll put here the same as 20 meters per second. Please, these conversions are necessary. Why? We can't deal with the kilometers per hour. Okay, go to 36 kilometers, okay, per hour. Since I've already explained what it means, I'm just going to direct. So this will be it is 36 times 1,000 over 3,600. Sorry, 3,600. Try to reduce and divide such that you can see what will be our final velocity, and I think that will give us a 10. Give us 10 meters per second. So even here, 10 meters per second. Please learn how we do the conversions, and I think that is the best way. Now next, let's now go on. Which equation? We want time. We want time, but we have S, U, and V. We want time. Any equation which has S, U, V, and T, we don't have it in those ones. So what we do, let's use that equation which has S, U, and V. Then we shall go back and get the T. And that is this equation there. So shall I say using, okay, V squared is equal to U squared plus 2AS. We know we want to get time, but we don't have an equation which has V, U, and S with the time together. So let's use this. We get the other known, then we can go on to finding the rest. So V is how much? 10. Okay. 10 squared is equal to U is 20 squared plus 2 times. The S is how much? The S is 800. 800 times now the A. Like that. So this 20 will come this side. That will be 10 squared minus 20 squared is equal to 1600A. But when you subtract here, that will be 100 minus 200 is equal to 1600. Like that. But A. This will give us negative 100 is equal to 1600. A. Divide by 1600. Divide by 1600. Now we are going to get the A. Once you get the A, we shall use some other equation to now get the final answer. So the A will now be equal to, these zeros will cancel, negative 1 over 16 meters per second squared. That is acceleration. Now one would ask, why is it negative? Please, whenever we are applying the brakes, it means that we are decelerating. We are coming to rest, decelerating. Therefore, we are reducing in the acceleration. So we always expect that whenever applying the brakes. A negative acceleration means a deceleration. We explained that in lesson 1. Okay, next. Now here, what we're going to do, since we have the A, now we can use this equation 1. Equation 1, so now can I say, using S is equal to U plus a half AT squared. Let's use that. The S is 800 is equal to U, which is 20, sorry, this is UT. 20 times, the time is the one we want, T. Oh, would that work for us? No. I think let me use the first equation. This one is a bit bulky. Let's use the first equation, but they all give you the same answer. But let's use the first equation. Yeah, I see the first equation is simpler. So using V is equal to U plus AT. Please, this also can give us the answer. So V is 10 equals to U, which is 20, plus our acceleration is negative 1 over 16 times T. Now that you can get the T. Subtract this side, shall get, okay, a 10 minus 20 is equal to negative T over 16. We have this. So now this will be a negative 10 is equal to negative T over 16. Okay. Now we shall say times 16, even this side times 16. So you shall get negative 160 is equal to negative T. Divide both sides by negative 1, both sides by negative 1. So now T will be equal to 160 seconds. Oh, is that so? If I'm not mistaken, did we even divide well? Did we even divide well? Let's cross check, please. Did we even divide well? Oh, by the way, there's some reshuffle which is meant to be done here. You realize that here this is an error. You see that 20 squared is not 200, it's 400. So that means that here we shall have 300 over that. So now that this one will be negative 3 over 16. So even here we shall put negative 3 over 16, negative 3t over 16, negative 3t, just that edit, negative 3t. So you shall have 3t is equal to 160. 3t is equal to 160. So therefore divide by 3, divide by 3. Now that will give us that t will be equal to, you now get to calculate and divide. You now get to calculate and divide. Sorry for that. Here we had not squared well, so this one will be a 160. Sorry, 160. Sorry, 160 divided by 3 up. Then this one is 53.33 for decimal places. 53.33 seconds. As simple as that. Thank you. Please don't forget to subscribe. I told you, when you subscribe, it is a token of appreciation which keeps us going to even add more topics. So you go there and subscribe.